So if f is differentiable at a, then f is continuous at a. And this is something we can use to decide if we can even find the derivative of something. So what it's saying is if it's differentiable a, that means our limit exists. So the limit of our difference quotient is equal to f prime of a. You can plug in a, you get f prime of a. And then if that's true, then f is continuous at a. And so we get to use our rules for continuity. Remember, the limit as x approaches a of x is equal to f of a. That this one exists, and that they're both equal. So if this is true, this is true. So one thing you want to note is if f is continuous at a, then f is differentiable at a is completely false. It's not true, and I'll give you some examples as to why right down here. But you can say that a function must be continuous at f of a to be differentiable at a. So if it's differentiable, it's continuous. So that's kind of like one of the conditions for it to be differentiable. Okay, so these are not differentiable at a. So if you look at these little functions here, each of these is not differentiable. Let's start with the middle one. You can just see that it's not even continuous. Coming in from the left and the right, we're approaching a different point. This is not continuous. So let's now focus on these two. This is a break or a cusp. You can see it looks like someone just broke the function. And this is a vertical tangent. So I've got a Desmos graph. We'll start with the break. So the blue here is our derivative. I can turn it off to show you it. So that's our function. And if you remember, as we move through the graph, that's a positive slope, 0, negatives here, and then you can see that it just disappears. That's an undefined value. That's a vertical tangent. And that one just does not exist right there. So it does not exist, undefined. So if I turn on the derivative, you'll see how they match. And so right here, this is a negative slope, and you can see that we have negative numbers. So the y-coordinate here of our derivative tells you the slope of that line. So the slope of this red line is negative 3.238. If I go back to when I have a positive slope right here, the slope of that line right there is positive. You can see it's a 2.142. That's the slope of that red line. So coming in from the left, you can see that I have a positive slope. See, positive slope. And then coming in from the right, you can see that we have a negative slope. So this is negative, this is positive. They're not approaching the same thing. So if we look at this over here, you can see this is positive, this is negative. They're not going to approach the same thing, so it is not differentiable. This would be like -2. This would be like a +2. Not the same thing. So the limit does not exist. And if the limit does not exist, it's not differentiable. So it's still continuous though. See, so you can't say if f is continuous at a, then f is differentiable, because that is continuous, but it's not differentiable. And that's not differentiable, and it's not even continuous. Now let's look at the last one. This is our vertical tangent. So if I take this back to here, right at 2, you can see it disappears. So at 2, there's nothing there. You can see here our derivative is going to negative infinity, and that's giving us our vertical tangent, which is not showing up. There is a vertical line going through there. So I can force it in with a little x equals 2 right there. That's our vertical tangent. And so we get an undefined value here. Our slope is undefined. Our derivative at a is undefined. So it's not differentiable at a. So this is differentiable a. That's what you're looking for. These nice, smooth, continuous graphs. No vertical tangents, no breaks. If it is not differentiable at those values. That doesn't mean it's not differentiable anywhere. It's differentiable here and here, but not here. See? So looking at the graph, we get derivatives everywhere else. That's got a derivative, see? We're good. If you follow it down, it would give it to you as well, but it's way down there. Let's go up here. See? It's differentiable here, it's differentiable here, not differentiable here or here. And so there you have it. Look for these three things. You know it's not differentiable. These are our absolute values that do this. Some of the radicals will do that as well. All right, thank you.